Okay, so here's my DIY Arlo Pro solar panel charging. So here it is. It became more like a hobby instead of trying to save money, but I think I end up spending a lot less money even buying all these kind of little gadgets. Uh, Here's one, the DC to DC converter. There's another one with a LCD. So my original plan, what I originally started with, was the same thing, the USB cigarette lighter charger, which was that one. Now when I connected it, it started charging and I was happy, and then there was a little bit of clouds and it turned off and it didn't want to come back up again. So I had to unplug it and replug it again, and it started shutting off in the middle, without, when the sun being fully shining. So I discarded that. I thought, oh man, but then this one is a 1,000 milliamps or 1 amp USB charger. Now I had that laying around in the house, so I'm not really sure if it was a good one or not. So my solar panel is a 12-volt panel. I saw a video, some guy was charging his battery from his I don't know what it was, a tractor or something, and he was reviewing like 3 different ones. So I went with the one that was charging the most, which is about 800 milliamps, 900 milliamps. I think it's rated for 1 point something amps, but it. So I went with that one. I just said, what the hell? It was like $24 on eBay, 24 or 28, I forgot. I'll give you the description later. And then I ended up buying all kinds of gadgets. So when I installed that one, it did work, but I didn't have no way of seeing exactly what was going on, how much energy was producing the solar panel, so I ended up buying the USB adapter. When you can see right now it's charging at 4.7 volts and it has 460 milliamps, and so far since I connected it I have 154 milliamps of current going through. So right now it's about 9 o'clock. The sun is not all the way up, so that's pretty good. 460 for being at 9 o'clock. It's darn okay. So the only difference I did when I went and bought this one, it does have the 1 amp and the 2.1 amps. So I connected to a 2.1 amps. Yeah, I had it for over a week now, just testing it, and it's been working just fine. So this one, the reason why I didn't like this one is because I have a little problem, and I still have a little problem, but it seems like during the twilight, I don't know if you say that twilight, right when the sun goes down and you just see, a little bit of light, I lose about 10 to 15% of my battery power from the Arlo. Originally, I thought it was during the night I was losing the percentage, but then I kept on checking my phone to see what the percentage was during the night, and it stayed pretty stable. I did check when I started checking it right early in the morning. I go to work at 5 o'clock, so I started checking it, and then I noticed around 6:30, 7 o'clock, I started losing power. And then so I checked it, and then after maybe 9 o'clock I started seeing the battery percentage go up again. So it goes from 100% down to, with this one, with a DC converter, it was going almost to 85, 88%, including that one too. With a cigarette lighter USB, it only goes down about 10%. Now I tried putting a diode to try to prevent the power from drawing it from the Arlo, but it didn't seem to do anything. The only thing it did is, with a USB, I lost about 0.7%. I mean, not percent. I'm sorry, 0.7 volts. So instead of charging at right now it's charging at 4.73. It was like 4 volts. With a DC converter, you could increase. It has the ability to increase the voltage, including that one. But for whatever reason, I still was losing the power. I don't know why. So I'm okay with it because 10%. I get it back right now. It's about I'm gonna say 9 o'clock, maybe 9:15. I'm pretty much almost 100% on the battery. I'll take a snapshot on the Arlo app and show you. So I did try smaller solar panels. That one I'm charging my. Oh, there's no battery there, but I'm using it for different project now. So that one was only giving me 150 to 200 milliamps, and I did notice that when this thing is fully charged, when the Arlo is fully charged, it's still drawing about 150 to 200 milliamps. Just to keep it to 100%, just the consumption of the camera, I guess. So that one was just barely doing it. Just it wasn't really charging it. It was just barely using the amps that it needs just to keep it connected. And during the night or the twilight, I was losing 10%. So my battery was every day was dropping 10%, and it wasn't able to recharge it again. So I discarded that one. Maybe if I would put another one, 2 in sequence, maybe that would have done it. But I opted to go with a 12 volt. That one, the little one is a 6 volt. The other one is a 12 volts. It's about I'm gonna say 14 inches by 14. It's a little square, a little bit over a square foot. So yeah. So I'm very happy with this setup. Right now I'm just testing it. I had it a week like that, making sure that when the sun, when there's cloudy, this thing goes up, because the solar panels, I guess they have they shut off if the current. I don't know exactly how that shit works. I'm sorry, I don't know how that stuff works. But this one seems to be working fine. If there's a cloud, the solar panel will start charging again as soon as the cloud goes through. So I haven't had any issues with over a week now. I might just remove that because I know that USB doctor is probably drawing some power too, but I really doesn't really matter because the solar panel is providing enough power for everything. So maybe I'll leave it there. Maybe I'll just remove it. This one just gives you a visual on how much like right now. So I'm gonna let's see if you can see it better. It's 495, 520, 490, 520. I don't know how accurate these things are, but it seems to be working for me. 500 milliamps is plenty. Like I said, you need about 200 milliamps just to keep that the unit topped off to 100%. So to me it's working. So yeah, this is a true DIY solar panel Arlo Pro setup.